Hello, everyone. Welcome to This Week on Mars. My name is Ian Hewitt with the Gupta College of Science here at Coastal Carolina University. And this is our weekly podcast where we talk about what's going on Mars, specifically with the Perseverance rover, Mars 2020 rover. So this week, we're going to continue to talk about the further adventures of Ingenuity. I know it seems like we focused a lot on this the last couple of weeks, but that's because this period of the mission is designed to really test out this technology, the helicopter on Mars. Of course, this is a picture of it. Really, it's more of a helicopter drone, but that's the idea is that we're supposed to be testing it for the first month, and basically when that's happening, the rover has to kind of just basically stay in the same spot and watch it and make sure everything works. And if something doesn't, it's got to be there to capture what happened. So that really prevents other science activities from going on. This is part of the plan. We're coming to the end of that month, so as starting the rover will start moving as of next week, and we'll start looking at new things. So we should have some more updates. But let's talk about Ingenuity and the really successful program that this has been. So last time we left Ingenuity, the last video, we had done the unlock test and did a low speed rotor spin test, and that worked. Had a little trouble with a high speed rotor spin test, yes, absolutely, but got that fixed. We did a first test flight. That was the really simple one where we went up and went back down, pretty basic. Second test flight, we went up, went a little bit, came back, went down. All within the view of the rover's camera on the mast cam. That's the sort of if you think of the neck of the rover and the head, the piece that sticks up, that's really the mast cam. That was all done in the view of that because they wanted to make sure if there was a problem, they could capture what was going on. So now what they started doing here in the last couple of weeks is they actually started doing a little bit more aggressive testing. Now that they know the rover flies, or sorry, the drone flies. The rover doesn't fly, and that it can fly well. They want to start seeing just how well it could fly. So I remind everybody that we have this first Martian airstrip they call Wright Field. We've got the rover, where it landed. You can see the dot here. Actually, let me put my pen up, and you see you've got the rover location where it landed. Here's where Ingenuity is, and here's the test area. So basically, it's about the size of a football field, and so and where the rover if you want to kind of look at it more from the side, the rover's actually up on a little bit of a rise. They call it the Van Zyl Overlook, and watching where the helicopter deployment location is. You can see this is where the rover dropped it originally, and that's the test area, the flight zone, the Wright Field, a fairly flat area. And so the third flight was on Sunday, April 25th. This one is different because what it does, and let's see, we'll go ahead and kick on the video here, is what made it different is this is the first time it was flying the entire length or most of the length of the football field. And it was flying outside of the range of the mast cam. You'll see it actually pop in on the left-hand side here. And well, actually, there it goes, takes off, and then it will just kind of start its forward translation and really start moving. And actually, it's moving. It actually gets moving pretty quick, and it'll actually fly off camera for the first time because they have enough confidence. So what you have is the rover's mast cam isn't really designed to capture things happening quickly, so it's not designed to pan like a video. It's not like motion capture because there's not a lot of motion on Mars, so it's really meant to stare at things for long periods of time. So they can't really program it to actually follow. You see here it's actually coming back and landing. You'll see it as it gets to the left-hand side of the frame, it will actually come down and land. Very well done and working just perfectly, and that's great. So this is actually an important flight because it was higher and farther. It traveled basically half a football field or maybe a little bit more. It got up to about 6.6 feet per second. That's pretty fast. Think about that. That's like 2 yards a second. So that's a pretty good clip for the rotor. The other thing that was important about this test is that it's a farther test flight than they ever did on Earth. They did a lot of short test flight on Earth, but they never really ran it up and went the distance. Partially because it would have to be in a very large vacuum chamber, and we don't really have any vacuum chambers that are big enough to really get, this kind of distance. So, so the good news is the flight was perfect, and this basically allowed to move on to the next phase, which we're going to talk about. And this next phase is an even bigger test. So this is one of the ground images from the third flight, and you can see that this was in color, and you can see that it takes really good images. The one thing about these images is up through the third flight, Ingenuity was taking these images, and immediately transmitting them to the rover, and then throwing them away. Right, and so you got these kind of pictures, and you can see it's actually really good. You can see a lot of little small details and everything. That's going to be important for the future. So what's next? Well, the fourth flight, April 30th. This is even higher. It's going to be like 16 feet in the air. It's much, much farther. So much longer than a football field, 436 feet, and then return. But one of the differences, this is no longer going to be in the practice airstrip. This is the first one where it's actually going to fly out over an area that's not in the practice. The other thing is this has they're actually going to start utilizing it in more a real mission mode. What that means is they're going to take images, and actually the rover can I keep saying rover, apologies. The drone, the Ingenuity, can take multiple images. A lot of images, and store it in its onboard memory, and it can do that because when it's farther away from the rover, it can wait till the rover gets fairly close and then transmit its data to the rover. Hasn't been doing that up till now, but now they're actually going to test that. So they're actually going to take they're going to take a whole series of images on this flight. And the other cool thing is someone said, well, we have two cameras on the rover, Perseverance rover, one high up on the mast cam. Again, that's like the neck. We think of the neck and the head. It's up there, high up there. So let's try to get the sound of the rotors, and that would be the first time we've ever gotten sound on another planet. So the fourth flight took place, and here is the video. And yes, it does have sound, and we'll go ahead and kick it here. Okay, so here's the video, and you can hear that sound you're hearing is actually the wind, the Martian wind over the camera, and you'll hear Ingenuity. You see it down here on the right, and when you hear it spin up, it's got a really high hum. Even though it's a really high hum, it sounds like a low pitch sound. Because again, the Mars atmosphere is so much less dense, so it makes sound bassy or low. If you listen really carefully, you hear the Doppler effect. You'll hear the rotors change sound when it starts coming back. It's a little hard to hear. As video captions are saying, of course, that one of the things is that this is the first time we've ever had sound on any rovers, and the thing is, it really helps by adding another sense, so you can tell what's going on. You can hear Ingenuity coming back here and landing back in its starting spot. Really, really cool. So this is one of the images that was taken and we call it Airfield B, and I'll explain why we call it Airfield B. This is one of the images that it took. Again, it took and it stored. And the one thing about it is this fourth flight was a little different because it didn't fly on the test strip. It flew in the opposite direction. So it took a whole bunch of images of what it saw in the opposite direction. You can kind of see like a little low hill here on the upper right. And you see it's a fairly flat area. And the reason that's important, and they call it Airfield B, is with what's going to start happening now is they're going to move to an operational phase. So the picture on the right is basically showing you like the test field is the upper part here. And this is the direction it flew on this fourth flight, away from the test field out here. Why did it pick that direction? Well, that's because of the next phase. So NASA has approved going to an extended phase for Ingenuity. But that doesn't mean the rover's going to be sitting there again for another 30 days while it does more tests. What it means is it's going to be an operational phase. So starting with the next flight, which is supposed to take place the day this video is going up, but the data won't be back till later on this evening, is this will be flight 5. It's going to climb up to its operational height of 30 feet. But the difference is it's not coming back to where it started. What it's going to do is that Airfield B picture, somewhere near the end of this white line down here at the bottom, Ingenuity is going to go and take a bunch more pictures, and it's going to land there. Why is it doing that? Well, it's actually going in the direction where Perseverance is going to go, because Perseverance is going to start doing its science, and it's going to start traveling in that direction. So what's going to happen is actually Ingenuity will actually be scouting for Perseverance out in advance. So it's no longer going to just do where it comes back right back to where it started. It's actually going to be hopping ahead of Perseverance to look at things and to keep an eye on things or explore anything interesting. So this is really exciting because it's actually starting to move into a phase where it's actually going to be helping to Perseverance do science. So that's all been very exciting. For the first time, we've had a drone a helicopter drone on Mars, and just all the capability and the fact that it's worked so well. You can find a lot more information about this if you look on the Mars 2020 site at NASA, and there's lots of details on the helicopter if you're interested in how it works. Well, that's it for this week. Thanks everybody, and have a great week.